Good evening. I hope you are feeling so cozy. Tonight I have a very interesting book that I would like to share with you called Exploring the Elements. A complete guide to the periodic table. I really love this book because the graphics are very beautiful and so interesting to look at all of the images. I also love how these complex issues, complex topics, not issues, are broken down in a way that is very easy to understand, or at least easier to understand. So, shall we take a look? Did you know that everything in the universe, from the distant stars in the sky to the ground under your feet, from the pages of this book to you, the person reading it, is made up of just 92 ingredients. These ingredients are known as the elements, and they are the building blocks of everything. In this book, you'll meet all the elements that we have discovered so far. In this book, you'll meet all the elements that we have discovered so far. The 92 elements found in nature, and an extra 26 elements that have been created by humans. You'll find out what makes every element unique, their roles in the world, and the ingenious uses that we have found for them. From the nitrogen fertilizers that help feed the world, to the platinum-based medicines that help to treat cancer. From the hydrogen used as rocket fuel, to the indium in touchscreen devices. Once you learn that it takes more elements to build a smartphone than it does to build a human, you'll never look at the things around you in the same way again. Isn't that interesting? Every time I read that, it just blows my mind. It's one of those things, it's like, you know it, but unless you stop to really think about it, you just don't realize how interesting it is. You know what I mean? We just become used to all these. Okay, I'm getting rambly. Okay, let's move on. This is so beautiful. I know it's simple. I just love graphics like this. So, something interesting about this. When I first got this book, I was a little overwhelmed with how they designed these pages. Because there are so many colors and just so many things to look at. But once I realized this is the table of contents, I actually thought that it was a really cool idea. So, they even use some elements to spell out contents. Let's see. There's the introduction, and then there's all of the different kinds of elements, and then there's the glossary and index. Oh, and I also want to note that they have a section listing other resources, which is always something I look for whenever I read a nonfiction book like this. It's always important to have multiple resources, because then there's something that you are really interested in. You can look into it more. Okay. So, let's take a look at the introduction. Building blocks of everything. the building blocks of everything, from distant stars to the ground under your feet, from the pages of this book to the person reading it. What are things made of? Humans have been asking and trying to answer this question for thousands of years. The best way to find out what something is made of is to take it apart, to split it up into smaller and smaller pieces until you can't split it up anymore. Scientists have done this with everything around us, from plants and animals to rocks and air, from leaves and lava to gemstones and eyelashes. Scientists have even split apart the light from distant stars to find out what those stars are made of. What they have discovered is fantastic, amazing, and mind-boggling. Everything in the universe is made of just 92 basic ingredients. These building blocks of everything are known as elements. How is it possible that just 92 ingredients can build so many different things? How can objects as different as a toad, a tree, and a human brain be made out of the same stuff? To understand how this is possible, you can think of the elements as being a bit like different kinds of Lego bricks. Mathematicians have calculated that it's possible to combine just 6 different Lego bricks in, wow, this is a big number, 915,103,765 different ways. That is crazy. I don't remember reading that the first time that I read this. Wow. Just 6 different Lego bricks and 915,103,756 different ways. Nature has 92 building blocks to play with and has combined them in different ways to form billions of different substances and objects. In this book, you'll meet the 92 elements found in nature and an extra 26 elements that have been created by humans. You'll find out what makes each element unique, their roles in the natural world, and the ingenious uses that we have found for them. What are elements? Each element is a substance that cannot be split into simpler substances. For example, if you had a lump of the element gold, you could cut it into smaller pieces, but those small pieces would still be pieces of gold. You could cut those small pieces of gold into tiny pieces, but they would still be pieces of gold. The smallest possible piece of an element is called an atom. One atom of gold is about 166 picometers wide. Picometer is a trillionth of a meter, so a gold atom is far too small to see with your eyes. In fact, you could line up about 1,000,000 gold atoms across a single human hair. In order to see individual atoms of gold, you'd need to use one of the world's most powerful microscopes. Under these microscopes, gold atoms look like tiny balls neatly lined up. However, atoms are not just tiny balls. They are more complicated than that. Each element is made of a different type of atom. So, to really understand what elements are and what makes them different from one another, we need to imagine our way inside atoms. What are atoms made of? Atoms are made of tiny particles called protons, neutrons, and electrons. Each atom is a bit like a tiny version of our solar system. Just like the real solar system, most of the stuff in an atom is concentrated at the very center in a clump called the nucleus. Protons and neutrons are so small you could line up 1,000,000,000,000 of them on the period at the end of this sentence. Electrons are even smaller. Here it shows you nice graphics. Carbon atom. The electrons are pink here. Protons are green. Neutrons are white. Here in the center. Protons and neutrons. The protons and neutrons are clumped together at the center like the sun. Here's the sun in the center. Here's the protons and the neutrons. Electrons. The tiny fast-moving electrons whiz around them in orbit like the planets. Here are the planets around the sun. Here are the electrons around the protons and neutrons. Each element is made from a different type of atom. The differences between their atoms is what makes the elements look and behave differently from one another. What makes the atoms different is the number of protons and electrons they contain. The element hydrogen has the smallest, simplest atom. Each hydrogen atom has just one proton and one electron. The atoms of other elements have a different number of protons and electrons. For example, oxygen atoms have 8 protons and 8 electrons, while iron atoms have 26 protons and 26 electrons. Sometimes the number of neutrons in an atom matches the number of protons and electrons. Sometimes it is different. The atomic atomic number of an element tells you the number of protons and electrons inside every atom of that element. Every element has a different atomic number. See the oxygen atom right here, the iron atom right here, showing you the electrons, protons, and neutrons. So far, humans have discovered 118 different types of atom, which means that we can name 118 different elements. Organizing the elements. Each element has a unique set of properties. An element's physical properties include the temperature at which it melts or boils, its density, how closely packed its atoms are, and hardness, and whether or not it conducts heat and electricity, which means lets heat and electricity flow through it. These physical properties help to explain how each element looks and feels in our hands. An element's chemical properties describe how it behaves when it gets near other elements, whether it will react with them, and how quickly this reaction happens. These chemical properties help to explain the taste, smell, and toxicity of an element. There are 118 elements, and each element has dozens of different properties. Around 150 years ago, scientists began looking closely at the similarities and differences among elements and began to spot patterns. These patterns were used to organize the elements into a chart called the periodic table. The periodic table is a brilliant tool for exploring the elements and for helping us to understand them better. The periodic table. The periodic table is a chart that lists all the elements in order of atomic number, starting with hydrogen, the smallest atom with just one proton, and ending with oxygen, the largest atom with 118 protons. The elements aren't just listed in one long line, but arranged in rows called periods and columns called groups. Elements in the same group share similar properties. For example, all the elements in group 1 are soft, shiny metals that react very easily with other elements. All the elements in group 18 are colorless, non-metal gases that barely react with anything. When the Russian scientist Dmitry Mendeleev first spotted these repeating patterns 150 years ago, he could not explain why they came about. Today, we know that elements in the same group have similar properties because of similarities among their atoms. When you look at the periodic table, you are looking at repeating patterns in the structure of atoms themselves. You can find out more about the history of the periodic table on page 207. Categories. In this book, we have used colors to highlight categories of elements that have certain things in common. Sometimes these categories include a single group from the periodic table. Other times they form a block in the periodic table that includes elements from several groups. These categories are the basis of the chapters in this book. Groups and periods. Groups 1 through 18 and periods 1 through 7. Each column of the periodic table is known as a group. Elements in the same group have the same number of outer electrons, so they share similar chemical properties. Each row of the periodic table is called a period. As you read across each period, the atomic number of the elements increases and the structure of their atoms changes. It's these differences in atoms, invisible to human eyes, that explains why elements behave as they do and explains the shape of the periodic table. So here is a beautiful graphic of the periodic table. Where did all these elements come from? The universe began billions of years ago with the Big Bang. This created the simplest atoms of all, atoms of the elements hydrogen, helium, and lithium. Atoms of most other elements we find on Earth were formed inside burning, collapsing, or merging stars and thrown out across space by giant explosions. A handful of others were made in the space between stars when fast-moving particles smashed into one another. The periodic table also lists a few actinides and super-heavy elements that we never find naturally on Earth. These have been created by humans by smashing other atoms together at high speeds. Exploring the elements. Chemistry is the scientific study of all the different substances we find around us, including the elements. When chemists come across a substance, they ask, what is it made of? What are its properties? How does it behave around other substances, and why? For 150 years, the periodic table has helped chemists to look for answers. It guided the hunt for new elements, and it helped us discover the relationships between them. It helped us to better understand what atoms are, and how they combine to build everything in the universe. Chemists have also used their understanding of the elements to build new substances that aren't found in nature. These include thousands of chemicals and materials we take for granted today, from plastics, fuels, and fertilizers, to food additives and medicines, from the magnetic alloys needed to generate electricity to the semiconductors needed to make computer chips. The periodic table is still an important map, telling chemists and other scientists where to look when they are trying to answer a question, invent a new material, or solve a problem. Building with the elements. The periodic table helps us understand the atoms of 92 different elements combined to build everything in the universe. A few substances, such as air and some alloys, are mixtures of elements, but most chemicals and materials aren't just mixtures. They are compounds made from two or more elements that have been combined to form a completely new substance. In a compound, the atoms of elements form molecules held together by bonds that are hard to break. Compounds often have completely different properties to the elements they are made of. For example, atoms of hydrogen and oxygen, both reactive gases at room temperature, combine to form molecules of water, a compound that is liquid at room temperature. Atoms of the reactive metal sodium and the toxic gas chloride combine to form molecules of sodium chloride, the salt that we sprinkle on our food. Turn to page 211 to find out more. Elements of the earth. Many of the elements we use are found in the form of minerals in the Earth's crust. Sodium chloride, or rock salt, is an example of a mineral. Minerals are solid compounds that are found in nature, and each one is made from a particular set of elements. Inside a mineral, these elements are arranged in a very orderly way to form crystals. Most elements form at least one mineral, and some elements form hundreds of different minerals. Rocks are made of one or more minerals mixed together. Water is a compound made from two elements, hydrogen and oxygen. It's a liquid at 59 degrees Fahrenheit, the average temperature on Earth's surface. This is why most of Earth's water is found as a liquid in ponds, lakes, rivers, and oceans. Water is very good at dissolving other compounds, so we rarely find pure water. It usually has many other things dissolved in it. Air is a mixture of different gases. They include pure elements such as nitrogen and oxygen, as well as compounds such as carbon dioxide and water vapor. So on this where elements of Earth are found. Earth's air, Earth's oceans, Earth's crust, and Earth's mantle. Oh, and Earth's core, of course, we can't forget that. Okay, these last 2 pages that I would like to show you, we have elements of life and elements of technology. Okay? So, elements of life. Oxygen, carbon, hydrogen, and nitrogen are the main building blocks of every living thing, including humans. In fact, our bodies are mostly made up of just 11 elements, plus tiny traces of boron, chromium, cobalt, copper, fluorine, iodine, iron, manganese, molybdenum, selenium, silicon, nickel, bromine, vanadium, and zinc. It sounds incredible that something as complex as a human can be built from just 26 types of building blocks. But remember that these elements aren't plunked together in a jumble. Inside our bodies, a few types of atom combine in thousands of different ways to form simple compounds, which are themselves the building blocks of bigger, more complicated molecules. These molecules, big and small, are the building blocks of different types of cells. And these cells are the building blocks of our moving, breathing, talking, thinking bodies. Some pretty cool socks right here. Okay. The elements of technology. Strangely, it takes more elements to build a smartphone than it does to build a human. Over thousands of years, humans have become good at combining elements in new and ingenious ways to give us superpowers, such as the ability to fly thousands of miles in a few hours. The ability to turn the energy stored inside fossil fuels or moving wind into electricity, and the ability to talk to anyone, anywhere on the planet, simply by dialing a number. However, humans are not very good at mimicking the natural cycles of nature, which recycle the elements inside rocks, minerals, and living things to be used over and over again. Many of the elements used to make smartphones and other devices are quickly running out. Mining and using what is left is putting tremendous pressure on our planet. These pages show you how to read the book because even though the ideas are broken down in a way that is easier to understand, it's still very complex topics. So I think it is very nice that they included a little guide on how to read it instead of just throwing you right in. And of course, the first element is hydrogen. But I will not be going into any more of the book today, tonight. However, if you would like to see more of this book, I'd be happy to share. You can let me know if there's a specific element you would like to look at. Or maybe a couple elements that you would like to see. I hope you are feeling so cozy, very relaxed. Maybe you learned something new. Maybe it was just a nice refresh